And in between, if you have any queries, if you want any step to be explained or repeated again, you can definitely ask me. I'm ready to help you. So today we are going to discuss one more prism problem. Prism. In the last session, I hope you discussed square prism followed by hexagonal prism. So today I would like to start with one more prism to make yourself comfortable with the development of surface parallel line development in pentagonal prism. Okay, whether my voice is comfortable for you? Anyone?
Yes, sir.
Okay, thank you. Okay, friends, from the section of solid, like projection of solid simple position followed by section of solid where you have drawn section plane, then you can identify sectional top view with the help of section plane conditions. Now, so you people are very familiar with the projection of solid simple position, how to fix a simple position or how to identify the top and front view of a solid. You read this question: a pentagonal prism, side of base 25 mm and height 50 mm, rests with its base on HP, such that an edge of the base is parallel to VP, nearer to the observer. It is cut by a plane perpendicular to VP, inclined at 45 degree to HP, passing through the center of the axis. Draw the development of lateral surface of the truncated prism. So in this question, there is no sectional top view. We have to draw only the development of lateral surface of the prism. Now, out of 58, any one of you can say what is the top and front view of this question? What is the top and front view? Top view will be a base or front view will be a rectangle. What is the top and front view of this question of pentagonal prism? In top view, what will you draw? Whether it is rectangle or pentagon? I need answer from you people because it's basics of unit 2. Rests with its base on HP. Whenever the base is on HP, what is your position of, I mean, top and front view? Then we will identify the position of solid.
Draw pentagon on top.
Yeah, good. Pentagon on the top view. What is the position of pentagon? Base is on HP. Whenever the base is on HP, your top view is always the base, whatever the shape. Here, pentagonal prism. So pentagon will be the top view. Front view will be a rectangle in case of prism. Such that an edge of the base is parallel to VP. One edge of the base always parallel to VP in this question. Now, anyone can say the position of pentagon with respect to XY? One
Corner pentagon.
corner pentagon. Okay, an edge of the base is parallel to VP. I always tell my students like as a shortcut, you can replace VP with XY. Whatever the condition given in your question with respect to VP, you just replace VP with XY, which means one edge of the base is parallel to XY. One edge of the base. So we are having 5 sides of pentagon. One side of pentagon must be parallel to XY. Next, nearer to the observer. What is the meaning of nearer to the observer? I have two possibilities. One, I can keep one side of pentagon is parallel to XY, nearer to XY. Another one far away from XY. Here the condition is nearer to the observer. So you see friends, this is the position of pentagon. While you are marking the front view notations, most of the time they will tell you as an observer you are standing here. See my cursor, as an observer you are standing here. With the help of that only you can complete your front view. So how will you mark notations for front view? As an observer, if you are standing here, you can see clearly this corner E, A, B, C. But D corner is invisible. How you are saying this D is invisible? As an observer, you are standing here. So if you check the question once again, an edge of the base is parallel to VP. Yes, which edge? AB is the edge which is parallel to VP and nearer to the observer. So as an observer, I'm standing here, it is nearer to the observer. You have one more possibility. Instead of nearer to the observer, they can say nearer to it. Nearer to it, IT. So your information technology nearer to it instead of observer. The meaning is parallel to VP and nearer to the VP. In that case, this pentagon shape must be inverted. So the side must be parallel to XY and same the time it must be nearer to XY. So that problem we discussed in pyramid. So same pentagonal pentagon as plane surface, but we as a solid we discussed in pyramid. Okay, so you have to be careful with simple position. Even though you solved many problems in projection of solid, section of solid, I can say that you may not come across this shape of this shape or this position of pentagon in your previous cases. Okay, you may mostly you may solve like one edge. This AB edge may be parallel to HP, which means perpendicular to XY. That is how you solved many problems. Okay, so this is entirely new for us. Whenever they are saying nearer to observer, it is far away from XY. Nearer to it means it indicates this vertical plane. In that case, it is nearer to XY, this base edge. So I hope you are all familiar with front view. We have to always start our answer simple position with thin lines after completing the section plane. You have to convert the remaining portion of the solid into thick. Removed portion we can leave as it is in thin lines. Okay, that's why we started the answer with thick line. You may ask, sir, you are saying we have to start with thin lines, then why you drawn this pentagon as thick line? So I'm just very sure about my answer. That's why I started the entire pentagon will be the remaining portion of the solid. I know the answer. That's why I started straight away with a thick line. If you know the answer, you can start your top view as a thick line. If you have little bit confusion, if you are not sure about your remaining portion of the solid, it's best is to start always with thin lines. Okay, it is cut by a plane perpendicular to VP, inclined at 45 degree to HP. Okay, we are going to draw a inclined line 45 degree from XY where it's supposed to pass through, passing through the center of the axis. So the height of axis is 50 mm, center of 50 is 25. So take 25 mm. Before that, you can give notations. I hope you are all very comfortable with these steps. It has been taught you since projection of solid, then followed by section of solid. We are in development now. He may told you that the simple position is the fundamentals, basic from unit 2 to till unit 5. So till unit 5, you have to be very confident on simple position. This is the first and foremost step of any problem. Now we have marked this 25. So 25 mm dimensions, which is the center of the axis. Now you can go for 45 degree inclination line, which passing through the center of the axis. Okay, make it as 45. So this is our section plane. We have to transfer this thin line into section plane representation, where thick line followed by dot and dash, small dash in both the ends of this section plane line representation. Okay, now you came to know what is the removed and remaining portion of the solid. The top is the removed portion of the solid, bottom is the remaining portion of the solid with respect to section plane. We have to convert the remaining portion of the solid into thick line. So I transferred everything, all the longer edges into thick line. Okay. Now we have to identify the cutting points of section plane. So first cutting point of section plane, if you refer, this is the first cutting point of section plane. Where it is cutting, the section plane is cutting on the edge, longer edge, E dash and T dash. Make it as 1 dash. Next one is on A dash P dash. A dash P dash, this is where cutting, we can make it as 2 dash. Next, you have a chance of making this as 3 dash. If you refer, this is S dash and D dash. While marking section plane cutting points, you keep it in your mind. You have to follow top view. Then it will give you the better understanding, and also you can avoid mistakes. ET we have first completed on ET, E dash T dash 1 dash. Next on AP, A dash P dash we have marked 2 dash. Check your top view, what is next here? BQ. That is your BQ, B dash Q dash. This is B dash Q dash. In this, wherever the section plane cutting, that must be the third cutting point. Okay, so 3 dash. Next one, if you check CR, C dash R dash, this is where the section plane is cutting. Make it as 4 dash. Finally, D and dash. So still it is hidden corner from here, invisible corner from here. That's why we mark by means of a hidden line, small dash lines. Make it as 5 dash, that must be represented in bracket due to invisible corner, invisible longer edge. So these are the 5 cutting points of section plane. So up to this, you may be very familiar from section of solid unit 3. Now we are going to start development. Anyone can say what is the procedure for development of prism? What's the next step we have to do? What's the next step? So in the last session, you have discussed hexagonal prism development. So you can refer that problem also. You can tell me what is the next step. What is the first step we can do for development of surface in parallel line development? Hello. Okay, so good response. If you see in development, we have to find stretch out length. Being parallel line development, the stretch out length will be like, if it is pentagon, 5 times of 25. You may ask, sir, why it is 5 times of 25? Each and every side of pentagon possess one rectangle. If you check the solid, definitely one side, each and every side of pentagon have one rectangle. So we should have 5 rectangle, being pentagon has 5 sides. For the same height 50. Base length of the side is 25. That's why 5 into 25. Stretch out length, you can first of all draw one more thin line from the top face of prism parallel to XY like this. Okay. From this simple position, you can take any distance as per your wish. There is no specific constant distance we have to fix. So you can take any distance you wish. Draw your first longer edge. What is the first longer edge? ET. E dash, T dash. So first you can mark E and T. The distance between the next base side, it is ET. Next one is AP. Refer top view. Always it gives you better understanding. ET, next one is AP. The distance between ET and AP is 25. All the sides of pentagon holds 25 mm. So after AP, next one is BQ. Mark BQ. Next is C and R. Next DS. Okay, D and S. Last one we have to complete the surface. Again, I have to come back for ET. So these are the 5 rectangles which holds each side of pentagon. If you have a doubt, you can refer. What is this? TP. TP is one side. Yes, TP is the first rectangle. Then you can refer PQ. Yes, PQ. Next one is QR, followed by RS, finally ST. These are the 5 rectangles held by each side of a pentagon. In development, this is the first and foremost step. After this length is stretch out length. If you say this T to T, this length is called stretch out length of development. 5 times of 25. Each division holds 25 mm. Okay. Now you can draw a line parallel to XY from this each and every cutting points of section plane. That is the first cutting point of section plane. This is 1 dash. You can draw a line parallel to XY like this. This 1 dash lies on E dash and T dash. E dash and T dash. So you can check corresponding longer edge in the development as ET. Here I am having one ET and another long edge ET is here. You can make it as 1 on both the sides. Next cutting point of section plane 2 dash, which lies on A dash P dash AP. So you can draw a line parallel to XY until it cross or it meets AP. Make it as 2. Third cutting point. From third cutting point you can extend. It is on B dash Q dash. On BQ we can mark 3. What about 4 dash? It is on C dash R dash. You can extend a line until it touches C or longer edge. Make it as 4. Finally 5 dash. It is on D and S. D dash S dash. So you can draw a line parallel to XY until it touches DS. Make it as 5. Now you can join all these things. So you know that the top is the removed portion, bottom is the remaining portion. So always start your base is the remaining portion as thick line. Now you can join the remaining points. 1 to 2, 2 to 3. Use scale to join 3 to 4, 4 to 5, 5 to 1. Okay, then 1 to T. So many of the time, I will say many of the students in my previous experience as this particular semester, they will leave the answer as it is. No, still you have to convert these remaining longer edges. Check here, 2 dash, 2p dash. It is the remaining portion of the solid. So you have to convert this 2 to p into thick lines. Similarly, you check for 3 dash q dash. Yes, it is the remaining portion of the solid. Make 3q as a continuous thick line. 4 dash to r dash, 4r. 5 dash to s dash. Even though it is a hidden line, but it is the remaining portion of the solid. So you have to convert all the remaining portion of longer edges into thick lines. This is the final answer of this question. Okay, development of lateral surface of truncated pentagonal prism. So if you compare to true shape of section in unit 3 sectioning of solid, here it is easy. It will save you more time in exam point of view. If you are preferring sectioning of development over sectioning of solid, it may help you to reduce your time for which one during exam time. Okay friends, if you have any query in this question, you can ask me. Otherwise, we would like to solve one more cylinder problem, and also that is the basic practical question. Okay, you may not expect everything given in your question straight away. If you have any queries in this, you can ask me. Okay, fine. So see, any one of you can say what is this question all about? A vertical chimney of 70 centimeter, not mm, 70 centimeter diameter joins a roof sloping at 35° with horizontal. The shortest portion over the roof is 32 centimeter. Uptime, the shape of the sheet metal which the chimney can be fabricated. In engineering practice laboratory, especially in sheet metal section, you may come across for preparing a funnel. If you did the exercise, you may come across this kind of sheet metal questions. Now, any one of you can say what is the section plane condition here? What is the section plane condition? Or you can say what is the height of the chimney or height of the cylinder here? And here, what new to learn from this problem is, again, it is 70 centimeter. It's not mm. So we have to do reduction in scale. Then only we can draw this particular answer. Anyone can say what is the height of this cylinder? Is it given in your question? Anyone can say what is the section plane condition? So it's an interesting and important problem. If you never come across this kind of problem in your regular class work, it will be very difficult for you people to solve during the exam. Now, first of all, if you take in olden days, maybe 10 or 15 years before, we would like to have a chimney like this in our rooftop of kitchen. So if you check, this is the chimney they are saying. This 70 centimeter diameter, it looks like a cylinder where you can say 70 centimeter dia indicates 70 centimeter of the cylinder diameter. Okay, joins a roof sloping at 35 degree with horizontal. This is the slope of the roof. The slope of the roof inclination is 35 degree. The shortest portion over the roof of chimney is 32 centimeter. If you check, this green is the chimney. The shortest portion over the roof, this distance alone, it is 32 centimeter. Now, you may clearly understood here there is no axis height given in this question. Straight away, they never said what is section plane inclination, and also they never said what is the height of the cylinder. Okay, so you people have to apply your concept, then you have to identify. So as I said, the 70 centimeter is too large, so we can reduce the scale. I always prefer everything in mm because we are following in standard unit as mm. All dimensions are in mm. So I'm going to shift this 70 centimeter as per my convenient length, diameter, by fixing a scale. So I set a scale as 1:20. What is the meaning of 20 is 70 centimeters, 70 divided by 20. 70 divided by 20, it is 3.5 centimeter. I'm going to use in terms of mm, which means 35 mm. Okay, once again I repeat, reduction in scale, this is 1:20 is reduction in scale. Whatever the value you are having, divide that value by 20. So 70 divided by 20, you will get 3.5 centimeter. I have to use everything in terms of mm. So 35 mm. Draw a circle for 35 mm, and you can divide. Most of the cylinder and cone problem, you may divide that top view circle into 8 divisions. That is what I did. I am going to divide this circle into 8 divisions. Okay. And for front view, it is self-explanatory. You people are very familiar how to complete a front view here. So, but still, I have a doubt how to fix this section plane as well as height of the axis. This axis height is not given, our cylinder height is not given. So I left the top. I don't know where exactly it is. So I just left it. Now you read the next step. Join a roof sloping at 35 degree with horizontal. Look out this chimney carefully. If you see the 35 degree inclination line on the longer side, longer portion of this is the shortest portion over the roof. This is the longest portion over the roof. Longest portion over the roof, if you check at the bottom, the section plane, if you assume this roof slope is section plane, it is starting from this corner. So I can start the section plane from this E dash, from this point E dash. All of you listen carefully. From this point E dash, where the inclination is 35 degree. So if you see my section plane from E dash, check carefully here at the end corner at the bottom of the longest portion of the solid. This cursor is not Disturbing you. Okay, fine. So if you see longest portion, it is start from the end point. So that's why I started from E dash. Now we can fix the height of this chimney. Shortest portion over the roof. If you assume this section plane is the roof, slope of roof which is 35-degree incline as per this sentence. 35-degree with horizontal XY. Now, shortest portion over the roof is 32. So you may not use straight away 32 here. You have to check with your scale. 32 divided by 20. It is 1.6 centimeter, which means 16 mm I have to take above this section plane on the shortest portion of the roof. Okay, 16 mm. 32. What is the scale we have chosen is 20. 32 divided by 20. So it is 16, not 16, 1.6. All dimensions are in mm. So I have to write in terms of mm, 16 mm. Now we can fix the top face of a chimney. Now, friends, if you see, it's one more interesting thing. It's one more interesting thing. We always solved the problem where above the section plane is the removed portion. With respect to xy, below the section plane is the remaining portion of the solid. I hope you people also solved many problem with this condition. If you refer this problem, it is entirely new. Here, above the section plane is the remaining portion of the solid. So this is the section plane. Above the section plane is the remaining portion of the solid. Below the section plane is the removed portion of the solid. This you have to be very careful, and also it's very new to you people. So you see chimney how it is. So this is the shortest portion. It holds 32 centimeter. Okay. Okay, friends. It's we finalized the simple portion as well as section plane. Now we have to obtain the shape of the sheet metal, nothing but our development. Okay. So in prism, here also the parallel line development method. Even though parallel line development method, there is a difference between your prism and which one? Cylinder. Okay. It's like again practical example. If you see different two-wheeler, if you can get, there are a lot of varieties: Royal Enfield, scooter, then any bikes. Okay, even though it's a bike, each and everyone have their uniqueness. Here, being a cylinder, you are having different methods, like different thing you have to follow based on that particular shape. Being a cylinder, we have to include our circumference pi d here. So the first step is same. Yeah, before that, what I left is you have to identify the cutting points of section plane. So A1 dash, A dash. This is the first cutting point. Make it as 1 dash. Next BB1. Always check from your top view. BB1. This is BB1 2 dash. Next is CC1 3 dash. It is in order. No need to worry about it. DD1 4 dash 5 dash. Once again, if you check, what about F1F? This is F1F. So F1F, it is exactly on DD1. So make it as 6 dash. On DD1, it is exactly on CC1. On this 3 dash point, make it as 7 dash. HH1, this HH1 is on the same vertical line BB1. With respect to 2 dash, we can make it as 8 dash. You may wonder, sir, why this 6 dash, 7 dash, 8 dash in the bracket? Since it is invisible from here. If you see this F, G, H, both, all the three is invisible from here. That's why it is in the bracket. So beginning it is same. You are going to extend a line parallel to XY from the top face. Yes. Now we have to find the stretch out length. So as we did in our previous case of prism, what we did is the base, whatever 25 mm base, if it is pentagon, 5 times of 25. And if it is hexagon, 6 times of 25. That is what we used to do it. Used to do. Here, being cylinder, always keep it in your mind, friends. Here you have to take pi d, circumference of cylinder. What is pi d? Pi is 3.14. Diameter of the cylinder is 35. So you don't forget here, whatever the dimension used to draw this top view as a circle, that value has to be used here. Okay, pi into 35. In case for you, you may set a scale as 1 is to 10. Here, in case if it is 1 is to 10, it may be 70 mm. So here you have to use 70 instead of 35. But you always keep it in your mind, whatever the dimension or diameter you used to draw here, that value has to be used to fix this stretch out length of the cylinder chimney. Okay, why sir this 35? Whatever the division you did, 8 division means here also you have to divide this entire pi into 35 into 8. If it is 12 division you followed, here you have to divide into 12 divisions. So that's why whatever the dimension value you used to draw this circle, that has to be repeated here. Okay, so you can divide into whatever the value you are getting in your calculator, you can put that value divided by 8. Make it as 8 division. What is that 8 division? You may note, you can see A to H. So here if you check A1, B1, C1, D1, similarly like prism, this marking is same. So A1A to H1, again A1A. Okay, friends. Now we have to shift all these cutting points of section plane here. So only the difference between prism and pyramid is how you are going to transfer this stretch out length. There 5 times of 25, 6 times of 25 in case of pentagon and hexagonal prism. Here that simply pi d. Now the procedure is same. From 1 dash you draw a parallel line to xy. A1 dash, A dash, the corresponding A1 is here as well as here. Make it as 1 on both the sides. So similarly, you can mark all the cutting points of section plane in your development. Sir, in your previous pentagonal prism, you extended only till BB1. Sir, why you extended till now HH1? If you have that doubt, you check your this point. Here I'm having B1 dash as well as H1 dash, which means BB1 HH1 lies on the same vertical projector. On BB1 division, I marked 2. Check here, BB1, it is 2. On HH1, it is 8. It will save your time. No need to extend the same line once again. So once if you are extending means you check how many points lies on the same line which is drawn parallel to xy. So 2 and 8. Next it is 3 and 7. 3 is on CC1, 7 is on GG1. So 3 on GG1 it is 7. Okay. Next is 4 and 6. 4 is on DD1. 6 is on FF1. 5 dash which is exactly on XY, E dash. So here correspondingly E, make it as 5. Remember friends, it is a cylinder, only the boundary surface. You are not supposed to complete this intermediate 8 divisions. Whatever the division if you are using, you are not allowed to convert that into thick line. I will tell you a story. Why? If you change that, what will happen? So the top face is the remaining now. In our all previous case, bottom XY is the remaining. Here the top is the remaining. And if you check again A1 dash to 1 dash remaining, join A1 to 1 on the other side A1 to 1. Being a cylinder or cone, you are not supposed to use scale here. You have to join you by freehand smooth surface. Okay, draw a curve by joining all 1, 2, 3, 4, 5, 6, 7, 8, 1 by a curve. Okay, this is the final answer of this question, development of chimney in sheet metal. Here, I will tell you, if you are not conscious, if you are not active, or if you, most of the times what students will do is what they did in prism, B1 to 2, C1 to 3, D1 to 4, they can change this into thick line. I will tell you a story. If you convert this into thick, it looks like a prism. because in prism only you will have intermediate longer edges in case of development. In cylinder only a boundary. In cylinder only a boundary. Even if you extend this division blue line, that's why I drawn in a different color blue line. If you drawn this blue line into thick after identifying the section plane, this indicates prism. How is it possible for you cylinder in the top view, prism in the front view? Cylinder in the top view, prism in the front view. So always keep it in your mind, being a cylinder and cone, only the boundary, only the outer surface, nothing inside will not be converted into thick line. Okay, it looks like you started as a cylinder, and without your consciousness you may transfer this 2 dash to b1 dash 4 dash to d1 dash as thick. I will tell you a story. You paid yeah, money to buy a car, but your company delivered you a bike. Whether you will accept it? No. That is how, if you compare this mistake with practical example, this is how you people are repeating these mistakes. So always keep it in your mind, for cylinder and cone only the boundary surface. You are not supposed to transfer this intermediate divisions into thick lines. Okay, so this is one of the most interesting practical development problem. You can expect this question for your end semester as well as cat exam. Whoever wish to test your knowledge without like a direct question where a section plane inclination and section plane passing through point is straight away given in your many of the questions. If they wish to check your knowledge, they can take this question. If you are not prepared for these kind of questions, definitely it will be difficult for you people to solve this question. If you have any query regarding this scale, and one more, even if you refer textbook, they may write it as 70 centimeter here, but as per engineering drawing standard, you are not allowed to write 35 mm here. Okay, you are not allowed to write unit with in nearer to the this dimension value. So you have to write whether all dimensions are in mm, all dimensions are in centimeter. In the from the beginning, you are following all dimensions are in mm. That's why I started with 535 and 16 here. Okay, here you have to be very careful. Whatever the dimension you used to draw this circle, that dimension has to be multiplied by 3.14. Okay, if you have any query or any doubt, you can ask me, friends. No doubts. Okay, I assume you are all very active listener. And let me check how many of you really listen to this session. If you are really a good listener, if you are a good engineering drawing student, and here you tell me only two things. This is also one interesting problem where we discussed in our session classroom. Any one of you can say what is the top view and front view of this question. You read this question and tell me. You read this question. It is also interesting question. If you get this question in your exam, if you are not prepared for this, definitely not even simple question you may draw it. In the chimney also you assumed cylinder, where chimney you assume cylinder, which means circle in the top view. Here it is also very difficult. Being hexagon, you have to draw the position of hexagon as right. And also that whether top view is hexagon, front view is hexagon, they never straight away given in your question. Second point, even position, they never mention what is the position of hexagon. Then third is sectioning plane, no section plane condition here. So this is an interesting question. If you can, if you have that capability, try and tell me what is the top and front view first, where you will draw hexagon, top view or front view. Being this quietness, I have a doubt whether am I connected to this long session. Okay, yes. If you see, friends, it's an interesting problem. I will tell you only the hint I will give you. You may wish to solve it. If you wish to prepare with your faculty, you can you can ask with him. Okay. So here, if you read development of lateral surface of hexagonal prism of 24 mm base age, 68 mm height. They never said base is on HP, base is on VP. The position, I mean, solid is sitting on this plane, that plane, like that. They never mentioned. An insect moves on its surface from a corner on the base to the diametrically opposite corner of the top face by short route. Trace graphically the path of the insect in the front view. Sir, what is this? It's entirely new for us. Yes. Here, you imagine, you just go back to your previous question. Graphically, the path of the insect in the front view. Always, you have to start your development on the rectangle side. If the front view is the development rectangle, obviously your top view will be the base hexagon. So from this last sentence, we can come to a conclusion, top view will be a hexagon. Now, there are two positions of hexagon possible. One where edge is parallel to xy, another one where edge is perpendicular to xy. How can we fix one of the position from that two positions? So you see, insect moves on its surface from a corner on the base to the diametrically opposite corner of the top face. Okay. So which means corner is on HP. Then only we can satisfy this condition. So you see, friends, if you have a corner, here I'm having another corner. I will complete the front view also. Then only you can clearly understood why I have solved this position of hexagon like this. Sir, you said everything must be in thin line. Then why you started with thick line? Here they never said that there is a section plane. If section plane is there, then only you can say removed and remaining portion. Here there is no removed portion. You can start everything by means of thick lines. Okay, whenever if you don't have a section plane, you can start everything by means of a thick line. Okay, now I will tell you why this hexagon shape is preferred, hexagon position is preferred. You see here carefully, P is the corner. Check here, P dash is the corner. Other side, diametrically meaning is this is diametrically. Opposite top face corner is D dash. Opposite top face corner is D dash. If I hold corner on both the sides, then only I can satisfy this condition from base corner diametrically to the opposite corner. In case if I don't have a corner on both the sides, in case I completed by having edge on both the sides, which means edge is perpendicular to xy, then your answer will be completely wrong. Not even you will get 1 or 2 marks, because you are the first and foremost step is wrong. And one more peculiarity in this question, you have to first complete your development, then only you can trace the shortest route in the front view. So as usual, hexagonal prism you can complete for 24 into 6 sides. Okay, you can take 24 into 6 sides. The same what you did in hexagonal prism or pentagonal prism. The same. After that, I said here there is no removed and remaining portions. You can change everything into thick lines. You can change everything into thick line. Now you see P to D. Okay, P to D is the corners. P dash is the bottom base corner. Top face corner is D dash. Diametrically join PD, then join DP. Now you have to reverse your procedure from this development to identify the cutting points. Okay, so 3, you can start from here, 1, 2, 3, 4. No need to give 5, 6, 7 again, 5, 6, 1 again. If you wish, you can add it. So with this alone, I can identify, you can join 1 dash to 2 dash. So you can join 1 dash to 2 dash, 2 dash to 3 dash, 3 dash to 4 dash. This is the answer. Graphically, the path of the insect in the front view. So this is also interesting question. So you can expect any kind of question in your end semester. So any faculty can change, set the question paper. You can expect any kind of question. So with this, I will close this today's session. It is exactly 12. So please bear with me for another 1 or 2 minutes. Let me close the attendance. Okay. Let me close the attendance. Your total strength is Abdul Hamid. Abdul Hamid. Roll number 2.